来年まで始めましょう。というわけで今日もコースラ。
That you've chosen to participate in this course. As you might expect, in a very first video for a course, I want to welcome you and just give you some basic information on how the course is organized and what will come next. So in one slide, this course is about an opportunity to learn the fundamental concepts of programming languages, and we're going to do it in a way that will, I believe, make you a better programmer in any programming language, and in fact, in programming languages that we're not even going to use during this course. The idea is really to learn the ideas around which every programming language is built and understand precisely the different ideas that we use when we program and how those unique perspective that studying programming languages gives you. So welcome.
で、ここにさっと流すと。
All right, in this optional video, I want to do two things. I want to give you a little background on who I am, just in case you're curious, since we'll be spending a lot of time together. And second, I want to acknowledge all the people you don't see in front of the camera that have been absolutely essential in making this course what it is. So in terms of me, here's a picture of the United States where I have lived all of my life. I grew up right in the middle in the suburbs of St. Louis, Missouri. When I was 18, I went off to college as an undergraduate at Rice University in Houston, Texas. I last lived in Texas in 1997. I missed the burritos. I then went to grad school in upstate New York at Cornell University. For those of you not familiar with Northeast United States geography, when you hear New York, you tend to think New York City. I was about a 4.5-hour drive from New York City. It's a rather large state. And then in 2003, I moved to the University of Washington on the West Coast, where I've been a faculty member in the Department of Computer Science and Engineering ever since. It's my favorite place to live. It's my favorite place to work, and I'm very, very happy here. A little bit about my research when I'm not teaching courses and online courses. I am a member of the Programming Languages research community, and I believe deeply in the fundamental elegance of the formal side of programming languages, things like functional languages, type systems, proofs about programs, and in general, formal semantics, and in particular, operational semantics. But I've been rather applied within that context in using that sort of foundation for messy real-world computing problems, such as how to write systems programs in languages like C, how to solve the difficulties of concurrent programming, which became much more important when we got to multi-core processors. More recently, even dealing with ways to try to continue to improve computing's performance in an age where our hardware is fundamentally limited by issues of power and energy. So I've always found this to be a really enjoyable, fulfilling strategy to collaborate with others on important problems from a perspective of sort of foundational concepts in programming languages theory. In recent years, I've also become more focused on computer science education. This MOOC is certainly a part of that, but more generally, computer science curriculum issues overall. I don't spend all my time on computer science. I used to do a bunch of things like go hiking in Montana. I did that, I think, in the summer of 2012. Play ice hockey once a week. You can't tell that guy in front with the helmet and the stick is me, but I enjoy skating around when I get the opportunity. I like to go on long bike rides. This is me finishing up a 200-mile or 320-kilometer bike ride here in the Pacific Northwest. And I even live with a dog. This is Red Dog. She's awesome. And as you finish each homework, she will visit you and give you a message. I've also traveled a fair amount, although I would love to do more. Here's a list of the countries I've visited. For fun, I put them in order from smallest to largest. I think there are about 25 of them. And I've traveled a lot around my own country. Of the 50 states in the US, I've definitely not been to Alaska, and I'm not sure if when I was a kid I made it to Delaware or not. I've certainly been everywhere else. But a lot has changed for me in the last couple years. In fact, since I first recorded most of the material for this MOOC, I had my first child in December 2013, and a second wonderful baby boy in September 2015. So I have no idea how I would have ever created an online course after I had kids, so I'm glad I did most of it before. I have no idea how I'm able to survive on as little sleep as I do these days, but having kids is the most wonderful thing, and it's a huge part of my life that you won't see in the course, but I wanted to show you a little bit about me, and that's a huge part of who I am today. Let me switch to the other topic of this video, which is acknowledging all the people you don't see in front of the camera. It's been an amazing journey with tons of help to make this course everything that it is. Way back in the summer of 2012, we gathered a collection of students, Cody, Rachel, Sean, Claire, Eric, and Max, back when MOOCs were just starting. There had only been a few, and we really had no idea what we were doing, but we put it together. These folks figured a lot of things out for the first time, and that'll always be a particularly special experience that they were able to be a part of. As the course continued and evolved, there were a later set of TAs that made things better, that fixed a lot of things, that were the important second crew. And then more recently, as we migrated to a platform that let people take the course more often and on a more regular schedule, there was another set of people that really had to redo a lot of the auto-grading infrastructure, and I appreciate that. All through the course, there's been volunteers who've served as community teaching assistants, community mentors that have provided a lot of feedback where explanations were unclear, a lot of extra practice problems, and an amazing commitment to discussion forums. There'll be more in the future, but at the time of recording this video, these are the names I have to share with you. Folks who helped set up the recording studio that I'm using to share this information with you. People at Coursera over almost 4 years now who have always been responsive to questions, given excellent feedback. This course certainly wouldn't exist without them. And then some extra special people who maybe were not as directly involved in the course, but a set of friends and colleagues that when I really needed something I wasn't quite able to do myself, provided special scripts and easier installation instructions and helped out in crucial times. There's a set of people that have been deeply involved in the course that I teach here on campus that is most similar to this online course, that have made the material better, that have contributed things over the years, and this course is certainly better because of all the work that they did. And then, of course, thousands of students who have participated in the course found typos, given feedback, said what worked well, said what worked less well. And in the end, it's an amazing team effort involving an enormous number of people. And while it's always my head in the corner of the screen and my voice coming out of your speakers, I did want to be clear here at the beginning of the course just how much I appreciate the massive effort that's gone on by a lot of people in order to make this course everything.
枠があればな、コースではという、つまりここどんなコースかという。
In this video, I want to talk about what the course is really about, programming languages, and why one might want to take a course about this sort of material. The idea is that we are going to learn the basic concepts that underlie all or almost all programming languages and how those pieces fit together. And while we're going to use the standard ML programming languages here in Part A of the course, Racket in Part B, and Ruby in Part C, we're doing so because it lets the concepts that we want to study really shine and focus on the key ideas in real languages where they tend to be easiest to learn and focus on what we want to focus on. And by using multiple languages, we can see how the same concepts, because we'll see some of the same concepts over and over again using all three languages, can look different when they sometimes are a little different, and more often when they're quite similar with just some basic syntactic differences in the different languages. And you could ask, why aren't we using Java or C# or Python or Scala or JavaScript? Well, in many ways, the languages we're using are simpler, and when we're trying to study the core concepts, simplicity is a virtue. The other thing I would emphasize, even though it's not in the course title, is that we will emphasize functional programming throughout most of the material that we study. So what does that mean? Well, we'll learn when we get there, but it means we're not going to have assignment statements or much in the way of mutating or updating the contents of memory, which may surprise you, and if you've never programmed in that style before, don't worry about it. We'll get lots of practice. It also means we'll use first-class functions and function closures, a really important topic, but one that I can't explain in a short video, so let me just leave the jargon there, and don't worry if you've never heard it before. And of course, we're going to do much, much more as well. So normally, you would spend some time at the beginning of a course motivating why you you should learn the main topics in the course. But in my experience, it's very difficult
Bugün
to
bir
do that until we've built up some
Ben
shared
Zoyana.
experience and shared terminology, and you've done a homework or two, or actually 3, to understand the basic ideas behind functional programming in particular and programming languages in general. So what I've done instead is made a collection of videos that motivate the course that will be delayed and will come after section 3 in the course. Now, unfortunately, that means you kind of have to trust me for now, or trust the students who've come before you who like to say things like, you know, at the time I was learning in this strange language and doing this strange stuff, but afterwards I was able to go back and learn things I had tried to learn before and found it so much simpler because you gave me the perspective and the terminology and the concepts I needed to pick up new programming languages and understand the programming languages I already knew better. So I'm asking you to trust me because if I try to motivate the course without having taught you the concepts, I'll just be using a bunch of fancy words and talking in abstract terms that don't make a lot of sense. But what I would like to say is one high-level idea that I deeply believe, which is that learning about this material will give you a new way to think about software that will make you a better programmer, even when you go back to the environments and programs and languages that you already feel comfortable with. That it will, on top of that, give you the mental tools and experience you need for a lifetime of confidently picking up new languages and ideas, and for being able to reason carefully, precisely, and correctly about the software you're writing. And I fully admit that as you get into the first couple hours of material in this course and do the first homework, it will feel like nothing you've done before in writing programs if you haven't done this kind of functional programming before. And maybe the best analogy I can think of are these movies, The Karate Kid. I remember it from my childhood, and it was remade in the 21st century. In this movie, if you've never seen it, I don't claim these are particularly great movies, but they are what they are. You have a kid who wants to learn how karate, a martial art, and is told instead to spend days and days cleaning windows and washing cars and doing other menial tasks. And it turns out that he's building, or she, I think in the remake, the muscle memory to do exactly what you need to be successful in karate. Now, I know nothing about karate, but I do know some things about programming languages and writing software, and I believe what we're going to do in this course, particularly early, is building those basic muscular skills and basic ideas that we'll then be able to build on very quickly in order to understand in a compositional way how more complex software and algorithms and programs can fit together in an effective way. So perhaps that analogy will resonate with some of you. It's certainly a good way to motivate yourself early in the course when you're doing something that feels very uncomfortable or unfamiliar. And indeed, I want to emphasize that here in part A of the course, we're going to use the standard ML language, which probably very few of you have used before. We may use the text editor you're not familiar with. What editor you use is optional, but you may not have a familiar development environment that you're used to for other languages. And we're going to evaluate our programs using this thing called a read-eval print loop that will feel different than the normal compile and run cycle that you may be more familiar with. You're going to have to install software you're not familiar with, and you're going to have to get these things up and running before you can really start on the content of homework 1. And I understand that's an extra burden, but I think it's also something that you will grant that in computing is fairly common, that as you take different courses, as you take new jobs, as you do new things, you're always working in strange new environments and installing new tools. And while it may be fun and often cause some complications and it can be aggravating at first, it's something you get more comfortable with time, and this course, like many, requires you to do a little of that right at the beginning so you can get started. Let me emphasize again, as I did in the very first video, that this course is not about ML, and when you get into part B, it's not about Racket, and part C is not about Ruby. These are means to other ends. These are chosen as languages that are particularly good fits for the topics we want to present. You could teach these concepts with other languages, but I've chosen these because I think they're particularly good tools for what we want to accomplish. And let me say right here in introducing the course that standard ML in particular is not a fashionable language that these days is used for real software. And that's okay because we're not in the homeworks in this course trying to build real software. We're trying to give you the background for building better real software in other languages in the future. So there are closely related languages that are very active and effective and still in much more common use today. In sort of decreasing similarity from standard ML, you have OCaml,
F シャープ
F#,
から、
Scala, and Haskell.
そうだろうな。関
Okay
係ないわ。
choice for
クラ
part
ス
A
が
of this
入ってるんだ。
course in various ways. I think standard ML is a slightly better choice. And in fact, I could argue, and will argue here briefly, that it's a bit of a feature and not a bug that we're picking a language that doesn't have a lot of modern libraries, that doesn't do a lot of things in the modern software ecosystems. That way we can focus just on the core ideas. We won't be distracted by trying to do anything fancy. We won't have a lot of complications that are common in modern software development. We get to focus on standard ML, which in many ways, even compared to these other wonderful languages, is clean, compositional, and elegant in ways we're going to start seeing even in the first week of this course. Let me also emphasize that these introductory videos are a lot of text on PowerPoint and me just telling you stuff. That's not the way most of the course works. I think that you learn about software by writing code and trying things out, and you'll see that we do that in a lot of the videos. There's in-video questions with quick quizzes on things. In short, I actually think that most of the videos in this course are better than the introduction videos, but introducing things is just something you need to get through, and we'll get on to the good stuff soon enough. In this video, I want to discuss the recommended background for the course, which is a very important topic, but also a difficult one to discuss, since so many people have so many different backgrounds that could be a good fit for what we want to study. So the key thing to emphasize is that on the one hand, this is not an introductory programming course. That the way I've designed the material assumes you have programming before, just in different languages. It doesn't have to be a lot of programming, however. If you've taken one or two other programming courses and succeeded at them, this will probably be fine. It doesn't have to have been courses. You could have picked it up on the job or done your own learning or whatever. On the other hand, this is not an advanced programming languages course. I typically teach this on campus to sort of second-year students, not people with years of professional industry experience or not even what I would consider a last-year undergraduate course. So it's not an introductory course. You should have programmed before, but it's not a particularly advanced course. I want to give you a little better sense of that. So here are some topics that I assume you would have seen when programming before. Things like variables and having arguments to a method or function or procedure. If you've called things methods, that's fine, but things that take arguments and return results. Some kind of if statement, some kind of branching for I do this in some situations, in other situations I do that. You've probably seen some sort of loop, you've probably seen some sort of array, even though here in at least part A of programming languages, we're not going to have loops or arrays. I do assume that you've seen recursion before. Now, we're going to get a lot more practice with recursion. We're going to use recursion on almost every problem, on almost every homework assignment. But we're going to go awfully fast if you've never seen it before. Recursion is the idea of defining some computation in terms of itself, defining some data in terms of itself, and we'll get lots more practice, but the way I've organized this course assumes some exposure before, and if you haven't seen that, you may find it a little extra difficult in the beginning. The next thing, implementation versus interface, the idea that clients of some code only have a high-level idea of what the code is doing and should not have exposed to them the implementation details, and they should not rely on those implementation details. This goes by a lot of different names like abstraction or modularity. You may have seen this in terms of an object-oriented programming setting, something that we won't do until part C of the course. It doesn't matter where you've seen it. And again, it's the sort of thing you may be able to pick up along the way, but it is kind of assumed background, the sort of thing one would see in a first programming course. I'll refer to some basic data structures like linked lists and binary trees that often come up in introductory courses as well. Method overriding or or subclassing is something that students generally have seen before, but we're actually not going to need it
OOP なら、
course,
これしか
and
な
then
ら基
it'll
本。
be reviewed. So of everything on this slide that you'd probably be okay without, this would be it. Now you'll notice I haven't really emphasized what language you need to have programmed in before because it doesn't really matter. I tend to sometimes assume more of a Java or C# sort of background, but not in the actual material, not anything you'll have to do for the homeworks or have to understand in a video. If you've only programmed in Python or JavaScript or something else, that's probably fine. What matters are the concepts on the previous slide. Now, sometimes in optional videos compare to Java for those of you that know it, and if you only know C#, Java will probably be fine. And I'll sometimes compare to C, which is a lower level programming language that is often a really nice contrast for some of the concepts we'll study in the course. But all of those specific language comparisons will always be an optional material. And one reason why it doesn't matter what language you've used before is that we're really going to start over from the beginning. That particularly early in the course, you may find it even more frustrating if you have a lot of programming experience because using ML can feel so foreign and so different. And that's actually a great thing because it means it doesn't matter exactly where your prior experience is. It's just we're going to go fast enough that if you haven't programmed before, it's going to just not make a whole lot of sense what we're doing. Okay, so what I want to do now is do an example of the sort of code that students at my university would be able to write or at least follow along with prior to taking the course that this MOOC is based on. Now, I want to emphasize that if you haven't seen Java before, this might not make sense. Hopefully some of it makes sense. You should also understand that as I write this code, first of all, I'm the teacher, so I know what I'm about to do. And second, I'm actually cheating. I actually have a copy of the code I'm writing for you nearby, and I just looked at it. So don't take this as intimidating. Just take it as an example of how throughout the course I am going to write a lot of code, and I'm going to discuss concepts as I write the code that should, even if they sound a little foreign to you because of the strange syntax, or maybe you haven't used exactly this terminology before, some of what I'm doing should look like programming and feel like the sort of thing you have seen before. So it'll give you some sense of what I mean by programming experience, but again, with all the different backgrounds and everything, it's just not something that I can promise will make sense to everyone, and that's okay. All right, so here I am. I often write code in front of you, and here is the only time for a long, long time I will write Java code for you. But in Java, we would declare a class for a binary tree of integers. This would be something where any tree that's not empty, which we'll represent with Java's null, will have an integer in it, and we'll have a left subtree and a right subtree. Those are the two child branches of the tree. So this is a data structure where each part of the structure has an int and then two other structures, which we're calling left and right. In Java, we would create one of these with something called a constructor, and this is how you define a constructor in Java that takes 3 arguments. And because I'm using a nice big font here, very little fits on a line. And then this would be some code. This is a method, although constructors are a little different in Java.
これはもう一回質問そう。
The fields of our object to, in this case, just be the 3 arguments passed in. We would create some. So it'll give you some promise will make sense to everyone, and that's okay. All right, so here I am. I often write code in front of you. And here is the only time for a long, long time I will write Java code for you.
バイナリツイートとかJava っぽいな。
A class for a binary tree of integers. This would be something where any tree that's not empty, which we'll represent with Java's null, will have an integer in it, and we'll have a left subtree and a right subtree. Child branches of the tree. So this is a data structure where each part of the structure has an int and then 2 other structures, which we're calling left and right. In Java, we would create one of these with something called a constructor, and this is how you define a constructor in Java that takes 3 arguments. And because I'm using a nice big font here, very little fits on a line. And then this would be some code. This is a method, although constructors are a little different in Java, where we would initialize the fields of our object to, in this case, just be the 3 arguments passed in.
リストに書かれると、
And that's how we would create such a thing.
なん
We
と、
could then write a method
ルートを作らなきゃい
on
けない
a
かな。
tree that would say sum up all the numbers in a tree. So just take a tree and
なる
sum
ほ
up all
ど。
the numbers. And the way I would do that, here I'm going to do it recursively, is I would compute an answer, which I'm eventually going to return, and I'm going to include the I field, all right, which I could write this.I, or I could just
これ
write
は再
I,
起
though
使う
this dot is
か。
not necessary in Java here.
じゃあ、
And
確か
then if the left child
持っていると
is
き
not
は、
null, then I need to add to
そう、 アン
ants,
ス
and
プ
there's a faster way to write this, I
レ
know.
プト。
The result of calling the sumAll method on the left child,
あ、なるほど、なるほど。
and I then need to further add on the sum of recursively
うん。
adding all
いう
the
格好
numbers
つけたいがい
in
いって
the
ことは
right
わかる。
child. And this is how you would do such a recursive algorithm in Java. And if I've made any mistakes here, I always fix up the code before I post it. I actually, of course, am coding in front of you here and maybe making small typos as I go. And that would be our sumAll method. Let me show you one other thing. And here I'm going to just paste this in so that you don't have to watch me type it all out. Here is another method. This one
スタティ
happens
ッ
to be
クイ
a
ンターマッ
static
プス
method,
あれ、
so it's a
スタティック
distinction
で
that
作る。
doesn't matter to us too much, that just takes in an array of integers that says nothing to do with binary trees anymore and just returns the maximum element. If you think about it, returning the maximum element for a collection doesn't work very well if you don't have any numbers. So this code happens to assume that the array has at least one element, which I'm putting in a comment here. And the way it does it is it starts with the first
あ、
element
ゼ
of
ロ
the
で
array,
エ
which
ラー
comes
出る
from
な。
0 in Java and in many programming languages, and then has a for loop that keeps seeing if the next element of the array is greater than the answer computed so far. If so, it updates it. When we're done with this for loop, we return the answer. So this is just an example of how I code in class in a language here that you may or may not be familiar with. But when we get into ML in the first real section of the course, I will go slower. I will explain everything I'm doing. But this is how I talk about programming. In this case, relying on some experience you may have seen, but more generally by explaining every little thing as I go. The class will feel a lot like this, but with everything explained one piece at a time. I want to discuss why the programming languages course is actually on Coursera. 3 courses, part A, part B, part C, why we made that decision and how the 3 pieces fit together. So the biggest reason we split it into 3 parts is because it's a large course. There's a lot of material. People who've finished the entire
200時間っ
course,
ていうの
part
は
A, part
大
B, and
変
part
だって。
C, have spent somewhere between 100 and 200 hours. It very much depends on the person and how quickly they go through the material. And so it just seemed like a lot, the way most modern courses, online courses are at this point, to call that all one course. This is something that corresponds to something that students in my university do over a 10 or
はい、
11 week
かなりこれを
period
ハードな
while they're not
分
trying
け
to do a
て、
lot of other things in their lives, although they are taking a couple other courses at the same time. Now, splitting it up was not easy for me to do. If you can imagine writing a novel and then having someone say, oh, I really only want to read the first few chapters, that's kind of how I feel splitting up the course. It really does all fit together. There are cross-cutting themes that only really make sense once you get to the end. There are neat things that tie together once you get into part B and part C. There are contrasts that we can't do until later the course. And overall, I put a lot of thought into what is in this course, and just as importantly, what is not. To have it all sort of packaged up as one piece that tells a consistent story from beginning to end. And I cannot emphasize enough how much I want all of you to participate all the way through to the end of part C. And indeed, the goal here was not to split it into 3 courses that try to make more money or make you think you're doing 3 times more than you're actually doing. And usually when I say the course, I mean everything. So what I've done here is basically argue that I shouldn't have split it up, but obviously we did, so let me now explain the reasons why we did. The biggest one is that there's just more material and it's more challenging, and you in some sense deserve the credit for completing 3 courses worth of material. And the places where we split it are reasonable intermediate milestones. They are places where you should feel very proud of getting
まあ、
this
一つや
far.
ってこれ
And
マイル
if
ストー
you
ンと
choose
や
to
ったっ
go
て
no
いう
further,
人
you
欲しい
will have
か。
learned something, and they sort of are reasonable stopping points that make sense. So you deserve recognition for that. It's something that when we had everything together, as we did when we first offered this MOOC, we didn't have. And so I think that's a great step in a really good direction. It will also give you a chance to take a break, if you will, that as you go through Part A, you really don't want to lose momentum. You want to do each piece of the course in sort of consecutive weeks so that you could keep track of everything. But if you wanted to take a couple weeks off or a month off before starting Part B, well, it might be a little tough to remember where you were and get started again. But again, because it's a reasonable stopping point, I actually think that makes a lot of sense. And so it's a way to kind of let you go through the overall course at a slower pace by going sort of at a certain pace for Part A and then taking a break before Part B, that sort of thing. So in terms of how it breaks down, I say unfortunately, each part of the course is done in a different programming language. I say unfortunate because it feeds back into this idea that the parts of courses are about the languages, where I keep emphasizing that they're really not. But nonetheless, that is how things break down. I should also emphasize that we didn't break it into thirds, right? We've picked the reasonable stopping points, and the way that worked out is Part B is definitely the biggest part of the three parts. And could we divide Part A into two smaller pieces? Maybe we could, but I don't see a natural breaking point, so I didn't, right? So the way this breaks down is that Part A has 3 homework assignments and then a 4th substantial section that has no homework assignment but does have an exam. So to finish Part A is really 4 major units of the course. And Part B is only 2 more units, so about half the size of Part A, although the second of those units has what's usually considered the most challenging and also the most rewarding homework in the course. And then Part C, where we study object-oriented programming and then compare and contrast it back with the functional programming that we do in Part A and Part B, has just another 2 homeworks and then a final exam. And that exam it focuses mostly on Parts B and C, because you'll notice Part B doesn't have an exam, but refers a little bit to contrast with Part A, because when you get to the end of the course, you'll see that that's an appropriate thing to do. So altogether, things are one course in 3 parts. I hope you appreciate that. It's perhaps obvious, but I'll say it, that you can't really do Part B without Part A, and you can't really do Part C without Parts A and Part B, because they often refer back to earlier parts. And that's the story of how we divided things up, and we hope that you make the most of the material available to you in the way that makes the most sense to you.
グレーディングポリシー。
In this video, I want to go over how grading will work in this course. All this information is detailed elsewhere, so in that sense, you could consider this video optional. But I think it's helpful to highlight key points. I've also learned that people are less likely to miss key details if there's a video that goes over some of the information. I also don't consider grades to be a major focus in these sort of online courses, and I hope that's true for you as well. But I know these things matter to people, and so I want to have a clear policy and make sure everyone understands it. The key issue in this video, of course, is what the policies are, but I also try to give a bit of rationale to justify why. That can help things make a little more sense, and also let me acknowledge that there are trade-offs and no perfect policy that's going to be the best fit for what everyone's trying to get out of this course. So for each homework, you will first submit it to an a computer program that will look at your assignment, run it on test cases, analyze what language features you're using, and assign a grade. And we do this in a more strict fashion than in many of the MOOCs out there. So the basic thing is to pass, you need to get 80%. I actually think that that's a reasonable bar. I hope you continue trying until you get 100% and fix things up. But that's the way it works. If we ever change that 80% threshold, I may not re-record this video, but I think it's at about the right place. And then the strict thing is that we're only going to let you submit at most once per day. Now, why are we doing that? I'll explain more on the next slide, but it really means you need to do the whole homework together. So what we don't allow you to do in any sort of reasonable way is do just the first problem and then see how you're doing, and then just the next little problem and see how you're doing. And I know that some of you would prefer that. but there are good pedagogic reasons to make it more like things on a traditional university campus where the homework is due at the end of the week and you do your best job as you can on everything and then you submit it. Okay? Now, the worst part is, with this policy, is when you make a tiny little mistake that causes your code not to compile, or if you upload the wrong file, then you're going to have to wait till the next day to submit what you meant to submit in the first place. And that's a casualty of this policy, and I apologize in advance for it. There's not a good, easy way to fix that, and I guess all I can really say is you'll only have to wait a day. Okay? So this is a stricter policy than most MOOCs, but it's than in a traditional university course. You get to keep submitting every day if you want to, although I really encourage you to do the assignment, really try to be confident you have everything right, and then submit it. And then if you want to try again to do better, well then, of course, that opportunity is available to you. I should also point out that this MOOC used to have a much stricter policy where you could only submit twice and then that was it. But in the more modern model, which you can continue in the MOOC learning until you can master the material and finish, of course, having a hard limit where you can never submit again doesn't make any sense. And so once per day is actually a pretty lenient policy compared to where things used to be. So what I'm really going for here is, unlike in a lot of online courses where you're just trying to get through a tutorial and move on to the next thing, I don't want you to keep twiddling and changing little things and using the autograder as a substitute for your own understanding of the material and your own testing of the programs. I understand that can be convenient, that it can be frustrating to put a lot of time in on a homework, and then when you go to the autograder, have it tell you lots and lots of things are wrong. But I truly believe the best way to learn this material is to focus on the assignment and think yourself about how the pieces fit together and is everything correct. And we give you a lot of help in the assignment, the types that functions should have, example test cases, so that you can do that reasoning on your own. And then the autograder can be just a sanity check when you're done. Okay, that's the idea. And if we let you just use the autograder as much as you wanted, then it'd be much, much easier to get everything. That's not the way to learn the material in the course. Now, I want to say there is no perfect policy. This grading policy is not perfect. There's trade-offs here. And it's just sort of the best compromise. I need to pick one policy for everyone, and that's what we've come up with. A few details and other parts of the course. That was the main autograder policy. So first of all, we have some challenge problems on the homework. They're not worth very much credit. They're just a few percent bonus, if you will. And I would love to get to take someone who turned in the homework, got everything right, and got the challenge problems right, and give them, say, 104% out of 100%. Now, at the time I'm recording this video, the Coursera platform doesn't let me give more than 100% the way we're doing the auto-grading infrastructure. So unfortunately, I can't give you more than 100%. You'll get it in your text feedback. You should feel very good about getting it. But in terms of your course record, it'll max out at 100%, and maybe we can fix that sometime in the future. Let me also talk about peer assessment, which I think is a really important part of this course. After you're done with the autograder for an assignment, then you need to turn in your assignment again for others in the course to look over your code and give you feedback on your style, and you're going to give feedback to 3 other people in the course on the style of their submissions. Okay? Now, the way this is going to work is you can on the Coursera platform participate in peer assessment at any point, but you should not until you've passed the autograder, and you won't be able to do it correctly because the file that has all the detailed grading instructions for peer assessment also has a sample solution in it, right? And therefore won't be available to you until you get that 80% threshold on the autograder, because otherwise you would have a sample solution sitting there right in a file available to you, which would be far too tempting and really demotivating for those of you working hard on the homework. So the idea is after you pass the grading threshold, then the peer assessment rubric will be available to you in that separate file. Then you can participate in the peer assessment, and you'll have that file that you need in order to do the peer assessment. Now, the actual peer assessment, I think, is really crucial both for learning a lot and for style, but it's not going to affect your grade very much. We'll make it worth a small amount. Basically, any score you get on the peer assessment is enough to continue in the course. and it'll just have a modest kind of 10% effect on your overall course grade. So we're doing this because just passing the autograder would give a bad impression on what's important in the course. The test cases are not everything that matters in writing clean, elegant code that demonstrates you understand the concepts in the course. And I've learned that people learn a ton by looking at others' solutions and getting feedback from peers on their own work. So it's really important to be kind and helpful. We're doing this not to create a mean grading system, but in fact to provide a constructive opportunity for everyone to help each other. And we've tried to structure it in a way that will be meaningful to you in learning the material without being too time consuming. The exams, when we get there, right, there's one at the end of part A and then a second one all the way at the end of part C. Like on the programming assignments, you can take it at most once per day. You need to get at least an 80%. And I want these to be timed exams. Now, the Coursera platform at the time of this video recording won't enforce a time limit, but part of the honor system is obeying it so that you study for the exam and then take the exam. And if you don't do well enough because you studied the wrong things, then you'll have the opportunity to take it again. But I don't want you to just open the exam and then go and look up each question and spend hours doing it that way, because I think you will learn far more by studying for the exam than you will by just answering the questions on the exam. Now, what's the exam going to be like? Well, we'll get there in a few sections, but we provide practice exams, which will give you a good sense of what questions would be like, and it's an opportunity to really engage in the material in a different format than just writing programs and participating in the autograder and the peer assessment. So with that, we are through the grading policy. I apologize for marching you through those details, but I do think the homeworks and exams, including the peer assessment for the homework assignments, are a great way to learn this material. Certainly you will learn far more by doing the homeworks than just by watching the videos, and I hope you'll enjoy them as challenging exercises that will stretch your mind and cause you to learn a lot.
大変そうだな。
The last topic I want to cover in the introductory material before we really start the course and start on this amazing journey is just a high-level outline of where we're going. And I want this to be optional because, first of all, it's fine to just start and see where we're going as we get there. But also because there's no way to discuss the course in just a few minutes without using a bunch of jargon and terminology that I don't expect you to know yet. The whole point of taking the course is so that you learn about these things.
First
And I would
class
hate for you
function.
to watch this
Roger.
video, think, I have no idea what he's talking about, I guess I shouldn't continue on. When that's exactly why you should continue on, so that you can learn about all these things that we'll explain one piece at a time. With that said, let's kind of give the overview in case you've seen some of these things before and want to know, am I going to get to some new stuff? Or I've heard I really want to learn about something, is that going to come up? I'm certainly not going to list every topic here. You'll be able to, there's just too many, right? There's many weeks worth of stuff. But at a very high level, here in part A of the course, we're going to do the basics of functional programming in a statically typed language, namely ML. So we're going to start with basics, things like variables and scope and numbers and addition. Don't worry, of course you've seen that before when you've programmed before, but we're going to do it in a precise way. We'll build up to functions, which are like methods but without objects, if you've seen object-oriented programming. We're going to do recursion. In fact, it's the way we're going to write iterative computations as well as other computations. We're going to have ways to build larger data structures, both tuples and lists. And that's all going to be in section 1. So with that and the software installation stuff, it's a fair amount, especially in an unusual environment. So we give extra time. That's really like you'll have about twice as long for that section as for the ones that follow. After that, section 2 is all about data types and pattern matching. This is a new way that most of you probably have seen before to represent data structures, to model different data. It's a great way to think about traversals over compound data structures of different types. And that'll be the focus in section 2. We'll also do a little bit on tail recursion, which is the key thing you need to understand in order to use recursion efficiently in languages like we're using here. Then in section 3, we get to what a lot of people think is kind of the biggest feature of functional programming, which is functions as first-class values, having functions that you pass around to other functions, return from functions, put in data structures. It's a large topic. It has a very interesting meaning, what it means to pass around functions, and that'll be our focus in section 3. And then in the last section of part A, we'll both learn type inference, how you can have a language with type errors, with a type system where the programmer doesn't have to write down types because the compiler infers them for us, and a separate but important topic of modules, support that ML has for collecting together types and values and functions over that type in a way that enforces that clients cannot misuse an abstraction. It's the way we think in this sort of language about separating an interface from an implementation. So overall, these are several of the key pieces that give you a precisely specified introduction to functional programming built up piece by piece, and these are the top high-level topics for part A of the course. Now when we get into part B, we'll first redo most of what we did in part A in a dynamically typed language. What changes, what are the trade-offs when you don't have very many programs being rejected before they run, instead you just rely on runtime failures in a dynamically typed setting. And we will get there when we get there. And then in the second unit in part B, we will actually implement a programming language using an interpreter, and that'll lead to a very nice discussion of how you implement programming languages, what it means to be a programming language and an implementation of it, and show you that you can also actually implement your own language, one that we give you, in fact, one that has first-class functions. So often the best way to understand something is to implement it yourself, and we are going to give you that experience with first-class functions. We will also, in that section 6, if you will, the second unit in part B, compare static versus dynamic typing. We don't do that right away in section 5 because first we want to get experience with dynamic typing, and then we can have a good discussion sort of comparing ML and Racket along this important design dimension where they make different high-level decisions. And then in part C, we now visit object-oriented programming, which many of you would have seen before, but it's okay if you haven't. And in the first unit, we sort of do some basics in Ruby and learn a lot about Ruby. And because it's our third language, we see that we can actually learn a lot quite quickly. We focus on how it's sort of even more dynamic than Racket and how it is even more object-oriented than you may be used to in languages like Java or C#, because in Ruby, really everything is an object. Even numbers are objects. And then in the last section of the course, we compare object-oriented with functional, and we do a number of more advanced object-oriented topics, things like mix-ins and double dispatch, and that makes the last homework of the course fairly challenging when we use some non-trivial object-oriented idioms to compare some of these ideas. So I really encourage part C. Of course, that's a long way off from us. A lot of people think, well, I already know OOP. I'm really here for the functional stuff, so I'm not going to do part C. I encourage you to continue to part C exactly for that compare and contrast and complementing things. I think it's also worth pointing out that some people who have done part C feel that I'm kind of anti-OOP and I'm somewhat unfair to object-oriented programming compared to functional programming. I think that's mostly not true. I have no problem with object-oriented programming, but I am somewhat purposely in this course pushing the functional perspective because it's the less well-known one, and I think it's a good opportunity to do so. And to point out that while, yes, there are situations where the OOP mindset is ideal, let's investigate some where the OOP mindset is possible, but arguably not ideal. So yes, there are some things in the last homework assignment that I make you do in an object way, even though that tends to be somewhat cumbersome. And this is not a criticism of any language. There are languages that encourage objects but give other ways to do things. There are languages that encourage functional style even when the functional style is not perfect. So you will not see from this course, from the beginning to the end, me say, one approach is always better than another approach. I do point out when the functional approach is a good one, sometimes even when it's a better one, but you will leave this course with a lot of food for thought and a lot of new perspectives, and that is my entire goal. All right, that's the introduction. Let's start and dig in with section 1 when you get to the next video.
About cost. This is also repeated in the course resources to make it easier to find those. This is an introduction to the basic concept of programming language. This is strongly importance of programming. The course uses the language Email in part A, Racket in part B, and Ruby in part C. ここからEmail をやったことね。As B course for teaching the concept. The real intent to about how together to make your nice. Learning advance. They need a particular resource for just about primitive. They give you a framework for understanding how to use the language constructs effectively and how to design correct and elegant programs. By using the language, you will learn to think more deeply than it terms the particular syntax of the language. The emphasis on functional programming is essential to learning how to write robust, reusable, composable, and elegant programs. Indeed, many of the most important ideas of modern language have their roots in functional programming. Get ready to learn fresh background. というわけで、this まずは ML を通してファンクショナルプログラミングの基本を学ぼうと。Recursion background 必要な前提知識。This course assumes students are familiar with programming covered almost in the introductory course. プログラミングという基本的なコースを修了している。But it is expected designed not to be particularly advanced course. 別にもっとアドバンスト。Students should be comfortable with variables, constants, arrays, lists, cycles, and recursion. Recursion will be reviewed and explained on. The difference between an interface and implementation. Students should be easier to write programs to language new than policy of the course is basic with original concepts consistent with the language. Familiarity with Java or closely related language, e.g. C# may be helpful, not necessarily for the Part C assignment. まあ、基本的なデータ型、アルゴリズム、リンクリストなど、そういうデータタイプ。データコードのをしておく必要があると。Because it's based on a course length for second and their third year undergraduate. だいたい大学2年か3年ぐらいということ。もっとファーストコンプサイエンスコース、もっとアドバンスコースで、もっとそうした質的な上のコースではないと。そういう冊に関わる everything creative at all. Course, second course is internalize and understanding of patterns and object oriented. 関数型プログラミングとオブジェクトオリエンテッドプログラミングについて、Develop skills necessary to learn new programming language. 新しいプログラミング言語について素早く学べるようになる。Specific language concepts such as they can understand and evaluate and elegant programming language their concepts. Attain reasonable proficiency in the email racket and Ruby, and as the byproduct become more. We hope you enjoy the course of amateur. The course isn't designed to be, because this is an opportunity to make available through experience at the core of computer science. A few pieces about this course. Give yourself time to get used to new language and programming. Like can be disoriented to learn and encounter unfamiliar error messages. I can get plans. まあそうだよな。新しい言語を覚えるので、多分フラストレーションはたまるでしょうし、新しいエラーメッセージが出るでしょうと。If your only goal is to finish the homework as quickly as possible, in this exercise will probably be to take a longer preparation. Instead, enjoy playing around with examples and small programs as you start to make them. 課題を通して小さなプログラムをやりましょう。A particular patient that determined during the first 2 weeks of the course. During this time, you will be learning programming that may feel totally unlike anything you have done before. I may be frustrating the more priority experience you have. Take it in our place. Once you get beyond our 2 homeworks, the course approach can feel much comfortable and thrilling. So we hope you find it all with. まあ、最初2週間ぐらいは、新しい言語にないのでかなり、ストレスが溜まるでしょうと。それを乗り越えれば楽しくなってくる。If you approach the course by saying, I will have fun learning to think in new ways, you will do well. If you aim to try to fit everything in system to the already record point, then you may get frustrated. By the end, of course, material will relate back to motivation. ダメならまた前にもちゃんと学び直せと。The course material will sometimes substitute, so don't be rushed to get through early material even if it's not ready to you. What is going on without all the details. We were building an important foundation. ちゃんと一歩一歩進めてみましょうと。First homework by thinking about how it relates to the lecture material. The programs you will write are often a bit more sophisticated than those in the lectures. You should be using the same concept. Especially in the yearly assignments, you will not need to come up with a large number of tricks run much beyond what is in the lecture. For the exams, focus more on the concepts than just how to write program. The exam question will have some each kind of question. The more conceptual questions are covered less for the homework, so you need to do more study though. Great peer assessment test has a great opportunity to learn by reading other people's code. Also find good examples so that not to learn what may get on. We truly believe peer assessment is more than quick. お互いのコードに力をつけましょう。待って、シンタックスパス、セマンティクスパス、イディオムパス、レバレージパス、トゥールス。ML ベーシックス、バインディング、コンディショナス、リコードファンクション。リカーシブファンクションとリカーシブタイプ。リカーシブタイプってあるの再起方。ベネッツとミューテーション。ベネッツとドミューテーション。変更不能型に点、アルジェルデートタイプ。アンマッチ。テールリカージョン。放置サイ。ハイオーダーファンクションズ、クロージャー。エクシカルスコープ、カリーカ、エクシュガー、エクイブレンス&エフェクツ。ハッピーラケット、ダイナミックバーサス、スタティックタイプ。レイジネス、ストリームズ&エモカ、パトシー、Ruby ベーシック、コントロール、ダイナミックス。いや、オブジェクトオリエンテーション、インペンスダイナミックです。なるほど。次の項目。Normal pathways on recommended background. This is optional reading, but if you are thinking you may not have the background for the course, いや、そのことは、please to read for the application path on done on Twitter. In one of the course instruction videos, I spent several minutes describing the application background, including showing an example in Java, even though programming in Java is difficult before or during. This may have the unintended consequence of scaling up obviously people who did and do this course. So let me try to give some additional flags. In the end, every person has a unique background and it's frustrating to live in general terms everyone, but we may or may not need to take this course. But I would like to do my best and I hope you are reading this before that you give course. 価値あるものをするように頑張っています。This main point I was trying to make is that this course is not an introductory programming course. これコンピューターサイエンスだからな。These are some great MOOCs and other online courses that teach programming assuming you have never programming before. This course comprehensive both by assuming only take 1 or 2 programming courses to combine in other ways. But some of you are taking courses now after these other courses maker. There are many different input intelligence courses and they cover different things. So I wanted to list some particular topics I am interested in house. For any one of them, the online resource webs discussion forums may help. Some students have done well despite not having some of the prerequisite background, but they may have goods. This MOOC is based on a course I have taught many times of many university on campus. On campus, I can assume that students will take a particular set of 2 industry courses. So my list of topics, I hope you might have best opinion. If unreasonable, but I wrote Java code quickly in the video. You don't need to have understand everything I was trying to quickly as I was learning. Since you course you use Java. You should also know it on all the video that I was well prepared before starting recording. This secret is that I had a copy of the code I was going to write to my screen. I had just looked it over in real life. まあそうだよな。ほぼこういうふうに言ってもらうんだ。Usually can't program that fast. Also, once you have seen yeah, I love the link to will be useful. I have think students who originally wrote introduced the videos were intimidating and remembering them. A few weeks later, the student watched the video again and could not figure out the name of them and the play. Overall, I want to encourage everyone to try out the course while giving a sense of the recommended background. If you are there are no harm in trying to pass one. The section 1 materials will have everything you need to do homework. Homeworks intended to be challenging and fulfilling, but they are not designed to require you know things about in this material. I want everyone to feel welcomed in the course to get everything out of it. Yeah. The beginning of a course can feel imminent to almost everyone despite that women still make a discussion for again, welcome. 次の項目です。Okay. When reading things, there is a video that covers much the same information. As you might expect, there was originally a single code programming language that we divided into 3 parts, part A, part B, part C. This reading explains why and how the 3 parts will be together. A video covers similar points, so no need to go over both. まあ、さっきビデオで説明したよねっていうこと。In many sense, Python language is a single course. 普通、プログラミング言語については一つのコースでできている。The concept build each other tell a single coherent story. Part A makes sense of only after Part A, and Part C makes sense only after Part B. The material was designed together and it's together a single to 10-week course by the Institute of the University of Something after Part A or Part B is like putting down a novel in the middle. まあ、どっちの章が終わっても You may have the great reading experience with detailed character and plot, but the author intended more you are getting the full story. Still, after careful consideration, Instructor decided to split the course into 3 parts for appearance. Total amount of material was difficulty of material is higher than the most of it. It is 2-3 times as much as many so much cost better communication. 過ぎた方がまあ覚えやすいし、受講しやすいし。Finally, learners who finish Part A or Part A and Part B have accomplished the tremendous amount of spending the course allows like learners to enjoy the things again. まあ、分けてやった方が後でやりやすい。Split into 3 parts are not the place to take a break. And then redeem its parts. The course makes such less ideal in terms of managing. A natural concern is that the split was done to make certificates cost more. This was not and it's not the motivation. In fact, because the instructor really wants you to do all these parts. そうだろうな。When you have made the base rule encourage you to continue. Part B and C cost less than Part A and the total is low 10 challenging weeks material. Most thinking about MOOCs have only for progression and maths count. The course is hopefully not a good reason for stopping in the middle. Not that sleep as all the name ranks. Instead, they are more natural place to divide the math. Part A has 3 programming assignments on one exam. Part B has 2 programming assignments, and one of which is nearly considered one of the most challenging and rewarding course. Part C has 2 language assignments and one exam. 学習教材。グレーディングポリシー。This reading is repeating in the course resource tab, so what you can more easily find it through the course. This information is also discussed in the video, with the human very minor details here. This video contains さっきのプレリングシーでビデオでやったと。When you think about perspectives, grades are far less important than everyone learning as much as they can with your course what they seek to gain. At the same time, we aim to create a challenge course where completion indicates learning area. The university level material. When language part A has 3 homework assignments has points. Each contributes 1/4 4分の1 not to the overall grade. For the homework assignments, part of the grade is assigned auto grader as some assignments peer assignment. You have to matter in your assignments separated by auto grading and peer assessment. You must do the peer assessment, the passing threshold for the auto grade portions and them is 80%. For peer assessment, participant services the access is low enough, it's basically not possible to meet. When submitting math types, calculate as maximum across submission. The prevent using the auto-grader exam results as a debugging tool. When submission was 1 per day, technically it is 22 hours to make things a little more convenient in some situations. This is much more inconvenient than the typical university settings. Here you submit once more. In private instance of this work, here you could basically submit once more. というわけで、大体1日2日でできるようにやってくれと。The goal is you gain your own confidence on your solution and work on your own after this area. However, no policy is backed at this submission rate, particularly in instances where you upload your own file. Beginning to understand why your submission is read by the auto-regulated for some reason. We apologize in advance for any frustration and need this situation to wait a day before trying to what you believe will solve the problem. The pretend homework there in week 1 may be helpful in this. Out of the honor code, this course is not posting anywhere. Ow! Listen to the fallbacks of other places by this. So it's about we related and right. Our goal is not to places to them. 基本的にコート上げるなって言ってるんだけどな。Discussion forum. Why are you participating? Why participating in discussion forums not required? This can be greater you data. Each feel constant can also seem to a little overwhelming, especially in over the course, so you might be 感覚上。ああ。I want to understand こんな感じでしょ。じゃあ、怒られそうな気がするが。難しいな。続けて、インストレーション、インストラクション。重要。そして1年ユース、SML、Emacs、SML、NG、all programming pathway will work with standard ML programming using the standard ML of New Jersey compiler. You need to use the text editor on your computer to the programming language. Any editor can handle plain text editor. You will want to editor that specifically supports ML. そっか、Emacs なんだね、全部からか。それちゃんと。Emacs because we want to you will welcome to use and install other Emacs. If you do the course stuff, you are likely to be able to help with any that arise. You may and help on the discussion. While Emacs doesn't have the look and feel or tool integration of many modern development Emacs IDs, that is versatile tool well known. Emacs は入ってないから好きじゃん。使いにくいんだけど、まあ、many computer science がそうであります。If you have not used it before, you will find the menus and key bindings used and the running user tool. Many users have used Emacs for the first time. With this course, I was in being like, we don't anymore. We are sensible enough that you need to be a power user with any person. All the system use Emacs for various reasons. This currently describes how this use Emacs SML and SML rendered for Emacs. Hence, for SML on your computer. This work isn't, for example, Windows. Windows 動くんだ。あ、そういや。Windows もあったな。This is a better June 21. The version number may change. When language part be used, the get and programming language pass you use to be. Because they will be multiple instances in your further when you get started. But the is Emacs. Recently recommend the Emacs version 20 for the for NX. グニューの Emacs から読み込めろと。さすがグニューっすよ。Windows 分もあるんだ。Emacs を Windows ある。やばいグニューミア。Max28。やばい、28日。入ってないだろうしな。コンテプス。これをダウンロード、ディベロップで、スタート、デマックスか。ミードってなかったっけ？待って。かつて開発されていた。あそうなのか。 開発停止されたから今ね、28を使いと。よし。この感じからして、bin、Emacs 18H、前を変えて、コピーしよう。そうだ。というわけで、Emacs をロールして、どくかなーっていう。システムプロパティで、HB か。そうです。この辺は、あること。近況。はい。これで再起動すればなるけど、今はできないから、このままと。ちょっと待って。そうすると、このさ、Emacs、あれ、出ない。じゃあこっちか。パスとしないからか。まあ、これしかないな。何メッセージをDIY want to look in the bin at TPMX。待って。BMX で。カートでみよう。待って。コロンス。ここで瓶の、ここやればいいのか。なるほど。まあ、ここでコピーして、やると、今のデレクトリに、Emacs とか、どうだろう。すべてのタブを一回閉じて、動くか。動かねえ。typegp.10bm は、受けて、アンパックして、ムーブでシステムの上に入れて、 そうだ。入ってはいないんだよね。なら、なら、まあ仕方ない。これで、しかないか。じゃあ、もう一つ。こっちの方で、Emacs。えー、えーまあいいでしょう。これでこっちはこれで動かす。よし。岡村と全部出たから、かなりパッてなってるな。どこ行った？忘れてるよ。あで、これはまた慣れていくしかないな。Windows ダンス、SMA で、MLNJ を、スタンダードメールをユーザーに。これをダウンロードしてインストールしろと。はあ、必要ならインストールすればいいとして、202.1。ああ、Windows サポしてないって。110.99。MSI。あどこで、大学です。110.99に、同じように言えば、110点。ダウンロードできねえ。フレーム、こうかな。つけてリンクを。なぜできない？あこうで、こう、両方できるように。 先をほど。どれだ。これか。これでやっといて、先をほど。うわ詳細。ダウンロードがブロックされた場合。じゃあこれは、これコピーして、Firefox で開いて、でを、で、これ、これでダメになってる。で、1、よしにして、これで、いいかな。うん。で、これをインスト。やっぱしこれは、この、スタンダード M ユーザージ。これよし。でき、ロールできたら、エキスポートパスイコール MacOS。まあ、ここにもあれだな。えっと、閉じて、SML できるか。入ってね。ちょ待って。ここら辺は、こういうことでいいかな。SML でバラスピード。MNJNF。うーん。ドットランで。はい、ダメか。えーと、そうするとアウトランの、今これで、環境変数に ML、J、パーセント。フルカーセント。ランクの MLJ と。こっちか。 ちょっとほら。あ、せる。とりあえずこれでいこうかな。これ、ない。じゃあ、直接飛ばしてみて。ウィンです。一応これでいこうか。32ビット。セミコロンってやればいいの。これ H。じゃあ、ビット。ダメだ。はいな。コンプレストリターンとする。なるほど。一応動くことは動いた。他物のあれをやってるから、HQ。よし、いるな、それ。待って、これの先生を信頼して、ここで、ML あるかな。ある。スタンダード ML ランゲーサー。アズール ML、シンプル ML。うーん。待って。とりあえず、いや、そっか。確か、ワワークスペースのハンドボックスに、岡村がヘロ ML だから、一応 ML サポートを入れてインストールして、デバッグ入るか。そうだな。そうなんでやってみるしかないのか。全全プラスセミコロンとやり、はてな。エラー出た。岡村だからか。じゃあ、そっか、あれだからです。これはダメだから、こっちじゃなくて、オーキャメルでそのまま行くしかな。まあです。いい。でも、 グニューウォークの SML モードを探せ。Emacs いいんだけど。でも、デビアンの方なら動くはず。あ、あの Windows じゃダメなのやっぱし。ケーブル X、ケーブル、で、こうしてできたら、一回エキストして、もう一回再起動。再起動して入り込んでるなら、SML で入れれば大丈夫か。コロン、XC とやれ。CD、フィルダーショー、テンプ、Emacs マイクのテスト、ML と。わかりますね。バル、オリから、CCS、コントロール C の、コントロール S、ML。と、なんでここに抜けるかな。いいとし、いいとしたら、SUD マイナス、アップ、SUD、アップ、IN、こっちの方に入れれば楽だな。ユニックスのインストラクションを見ろと。コンフィグ 10tg とアンパックして、ああ、リンクで、ZXVF の、おう、 バットも入ってる。10にするかな。C インストレッチメール。コピーしてやって。10スラッシ10スラッシュコントロール SH マイナス1。なのだ。入入って、自社入っててよかったわ。ないない。あ、YouTube 切れた。はい。で、今、コンパイルしてるから、ちょっと待つしかない。どうだ、まだコンパイルか。あとは、これからは、こっち側の環境でやれるかな。よかった。入ってない。どこ入ってる？よし。待てよ。いいのか。という。うわ入った。こっちでよかったじゃん。110.7K ちょっといいけど、これで S。おお、デメル入った。N、O、N、これ、よし。で、これ、わー、わー、全部一回消しよう。マインダブルテスト。 違う。テストの HTML で、スタンダード ML も一緒ならば、R です。そんなできるんだ。例えば、プラス、ゴール、慣れないとわからん。じゃあ、SML の、ワンラインのこれで、ならば、これで、信頼するとし、コードランナーで、NJS、のコロン、どうだ。いいけど、わからん。出力、こうか。トランとして。待てよ。これを閉じて、チルダー、ブックスのオッケーまでにとコピーで、ここでコードを移動する。設定は、Hello M からエンドボールのエンドセミコロン。ボキャブラに直してやんなきゃダメか。 プログラミングの基礎の方で覚えなきゃダメだな。OK。わかりました。一応 Emacs で覚えるからいいのか。なるほどね。そうすると、スレスで動いた。ここは関係なし。フーテストです。もう一回やってみよう。何で、で、それは LW プラス NW SM S SML L でやってみよう。S の、あ読みにくー。えあるじゃん。エリートフェイズですね、これやばいですよ。クラッチバッファー。N スタンスタンです。C、コントロール C。えーと、えっと、理由は、どうなんだっけ。覚えてねー。全然わからん。 プロセス X のフィニッシュ。FX。X と。ならば VAM でやってみる。あ、まり入れたくない。そうね、一応からいいのかな。これは慣れていくか。コードの方で SML 入れて、ランコードでいいかな。これで一応動くんだよな。で、ここでコントロール D で抜くしかない。コードだ。これ一応ここからいっか。Usable print loop。とりあえず増えたからこれ終了でいこう。はい、Emacs。4時。連日文化が。ビームでいいじゃんって気もするんだけどな。これと Emacs 系の人がちょっと。まあ続きま行きましょう。
This video, like all the videos in this section on software installation, is optional, but we put it together because we thought some of you might find it useful. Basically, before you can get started in the programming languages course, there are a few pieces of software we need you to install, and we have instructions for all of this. So if you go to the web page and click on the page about software installation, you'll find a link to this file, which gives installation instructions for various different operating systems, different versions of the software and whatnot. And while it's fairly simple to go through it and spend a few minutes doing it, you may have questions, and we thought it might be helpful for some of you to have a set of videos where I am literally going to install the software in front of you while the camera is running. So I don't claim that that's very interesting. In fact, I hope these are the least interesting videos in the entire course, but it might be useful. So the software we're going to install here in this first set of videos is going to take us through the first few weeks of the course. For later weeks, we'll need some additional software, but that's actually a bit easier to install. And as a last note, these videos are all going to be on Windows. The instructions can be a little different or a little more complicated for Mac or Linux, but those instructions do.
Windows だけでやったのこれ。
If you have questions, we expect people on the discussion board will be able to help you.
Emacs Installed.
In this video, we're going to get Emacs installed. So you'll see here I've got the PDF file open with all the instructions. I'm just going to scroll down to the Emacs section and then the section in there for Windows. Here's the key link I need, this .zip file. If you have trouble just clicking on it, instead just copy it into your browser. But I can click on it, it's connected to my browser. Here I want to save this .zip file. And it's going to go ahead and download this. It's about 50 megabytes, so that takes a minute or so. So I'm going to click pause just until that's done. Okay, we are now done downloading the file. Depending how your browser is configured, you need to find where that file was downloaded. I've got it here on the desktop, which is a fine place to at least get it copied to if that's not where it was originally downloaded. And now in the next key step, I'm going to right-click on this file and just choose Extract All. That will bring up this window. If you have another program you like to use to extract zip files, I'm going to click Extract. And this is again going to take a minute because now it's really going to extract all these files and get them pretty much installed. So I'm going to click pause again so you don't have to sit here for 2 or 3 minutes while it does that. Okay, we are now done extracting the files, and you'll see here a folder Emacs 24.2 bin i386. Let's open that. Let's get this folder from inside of it, cut that out, and paste it wherever you want. Just put it somewhere where you're going to leave it. So I'm putting it
まあ、ディスクトップに入れるわけにいかないから、
Just put it in one place that you're going to leave it there before this next step. So no matter how you got here, as long as you have this folder where you want it, you're doing great. Open it up. Go into the bin folder, and just this one time, run this add PM program. Go ahead and choose run. It's going to ask if we want to install Emacs here. We're going to say yes because we want. And that's it. We should be done installing Emacs. And we can check that by just going down to the Start menu. And you could just type in Emacs here on Windows 7 and choose that top option. Or in general, go to All Programs, GNU Emacs, and then this Emacs program.
入ってるですかに。
First time it'll
こっちでやれってことだったのか。
perfectly safe. So I would unclick this box, choose run, and when you see Emacs looking like this, you're done installing it.
ライブ見るのあってないじゃん。ということは、さっきのライブ JM やってないっていうのは、あともう一回入れなとこ。ということは、GNU Emacs を ZIP じゃなくてインストラでやんないと。Windows。プロ。ここに、やばい、GNUミラーから、ここでエデュケーション。Emacs っていう。インストーラーをデベロップにダウンロード。ということは、この瓶で Emacs を消そう。デベロップ、ダウンロード、Windows から、ここまで来ない。出せる。で、GPL で、 いいか。ディベロップマックス。よし。これでできるかな。お、動いた。Linux コードにも、Max。なるほど。これで動くんだ。まあいいや。じゃあ、コマンドラインからはどうかな。お、動いた。ここまでやんなきゃダメか。環境変数。おSML 全員。これを一回検索して。SML で言えばフォームが1に。これを消す。で、こっちで、これは欄言語だから上に持っていって、AT なんでしょう。そうすると、こっちのパスから、これを消して、あとは、終わったところでやればいいってこと。
So let's just click down here to the relevant portion of our instructions. Since we're here on Windows, in fact, on all the operating systems, we can follow this URL. If you can't just click on that, just paste it into your browser instead. So this is the web page we want to be at. And down here under Windows, there's just this .msi file. We can just click on that. My browser should ask me if I want to download it, which I do. Let's just go ahead and save that file. Your browser will put it wherever. If you get this download window, let's just go ahead and double click on that. That'll be fine. We can just click run. And then it's just going to bring up our little install wizard. All the default
あ
settings
と
are
は、
fine
ウィ
for
ザー
me.
ドに従ってインストールするか。
We're installing it. We are now completely done installing it. And now we just want to check that we installed it correctly. So we're going to run SML just right now differently than the way we usually will, just to make sure this part worked fine. And we just want to open a command prompt. You can just type CMD here, or if you prefer to find it, or you have a different version of your operating system, all
コマン
programming
ドプロンプトは古いからで、今だったら
command
Windows ターミナルだね。
So that's going to bring up this guy here. And again, just to make sure we installed SML correctly, just type SML return. Notice we get this interesting prompt saying we have standard ML of New Jersey version 110.75. The exact version is not so important.
もう79だった。
1+1 semicolon, indeed we get back 2, so it is working properly. And if you want to exit back out of this, on Windows anyway, it's Control-Z, hit return, and that's it. We have SML installed.
HTML も
Alright, now what we're going to do is we're going to get SML mode for Emacs installed. So we've installed Emacs and we've installed SML, but now we want to make Emacs convenient and useful for both writing and running SML programs. So we're going to do this entirely from within Emacs. So the first thing I'm going to do is open it. I'm just going to type Emacs here and run it.
これで動かすところが
Some slightly different colors here, and you're not going to see the menu bar. That is just formatting that I did so that it's easier to see on the video. You probably still have a white background, and that's just fine. So now I've opened Emacs. I'm now going to run a command metax list packages. So on a Windows keyboard, I'm going to type Alt-X,
metax
type list, either space, although it'll print as a dash, or you could type the dash, packages, and hit return. And what that's going to do, if you're in Emacs version 24 something or higher, is bring up a list of packages that are easy to install. If you have an older version of Emacs or you're not connected to the internet, you're going to have to follow some significantly more complicated instructions in an older version of SML mode, and the written instructions do walk through that. But assuming you got this screen to go up, you can just scroll down either with your mouse or with your keyboard down here to SML-mode, and then you can just take your mouse and click on that. That's going to split the screen in 2 here, so I'm now seeing 2 buffers in Emacs. Then you can just click on this install button. It's going to ask if I want to install it. I clearly do.
こうやって見ると意外とロー使いやすそうな気がするんだけど Emacs はキー配置が慣れない。
And then I'm just going to reopen it here and bring that back over so you can see it and get that nice big font again. And now we just want to check installing. So you want to open an SML file. Now you can use Control-X, Control-F, and then the file name to do this. Or if you have a file created, and I'm just going to create one over here on the desktop, I'm not going to give it a TXT extension. I'm going to call it something like test.sml. So I'll get a warning saying, do you really want to change the file extension? And I do. Because when you have something with an SML file extension, Emacs should now know that it's an SML file. So I can literally just drag that onto Emacs, and you'll notice down here on the bottom, the mode line says, I'm editing an SML file. So if you wrote SML code, which if you haven't learned how to do yet, you will soon, something like val x equals 3 plus 4, val y equals x times 5, you'll see coloring. If we had multiple lines here, you'd see nice indentation by hitting the tab key and etc. When I want to save the file, I type Control-X, Control-F. Now what if I wanted to run SML? Well, I'm not going to do that in this buffer, but I can do it from within Emacs. Anytime I'm editing a .sml file, I can just type Control-C, Control-S now. All I did was type Control-C, Control-S. What's come up is SML command SML, hit return. It's going to split my buffer in 2. And now here at the bottom, I do have an SML read-eval print loop where I could type 1 plus 1 semicolon and get 2. In fact, because I did that from that test.sml file, I'm in the same folder directory as I was over there. So if I want to load the contents of that file, I can say use, and then in quotation marks, test.sml and semicolon. And indeed, it just ran that program and said x is 7 and y is 35. So we have everything correctly installed. We can now use SML from within Emacs, edit our files in there, and we're all set with installation for the first half of the course. And you'll notice down here on the bottom, the mode line says, I'm editing an SML file. So if you wrote SML code, which if you haven't learned how to do yet, you will soon, something like val x equals 3 plus 4, val y equals x times 5, you'll see coloring. If we had multiple lines, you'll see nice indentation by hitting the tab key and etc. When I want to save the file, I type Control-X, Control-S. Now what if I wanted to run SML? Well, I'm not going to do that in this buffer, but I can do it from within Emacs. Anytime I'm editing a .sml file, I can just type Control-C, Control-S now. All I did was type Control-C, Control-S. What's come up is SML command SML, hit return. It's going to split my buffer in two. And now here at the bottom, I do have an SML read-eval print loop where I could type 1 + 1 semicolon and get 2. In fact, because I did that from that test.sml file, I'm in the same folder or directory as I was over there. So if I want to load the contents of that file, I can say use, and then in quotation marks, test.sml and semicolon. And indeed, it just ran that program. That X is 7 and Y is 35. So we have everything correctly installed. We can now use SML from within Emacs, edit our files in there, and we're all set with installation for the first half of the course.
なるほど。あれこれはまだ後だから、今日はやめますか。時間的にね、もう1時過ぎてるので、今日はここまでにつきましょう。では、一応動いたので、ここまでにつきます。では、ありがとうございます。
ディスコンネクト。